In question 10, we have a diagram that shows part of the curve with the equation y equals 4 upon 2x minus 1 whole square and the lines x equals to 1, y equals to 1. The curve passes through the points A and B. We have to find the exact volume generated when the shaded region is rotated through 360 degrees about the x-axis. Now the formula to find volume is pi times the integral of y squared and the limits b and a. Now, to find the volume of the shaded region, we can see that it is above the line which has an equation y equals to 1. So, to find the volume of the shaded region, first we will find the volume under the curve using the limits 3 upon 2 as the value of b is 3 upon 2 and 1. Then find the volume under the line and then subtract the two volumes to get the volume of the shaded region. Now, for the curve, we have the equation y equals to 4 upon 2x minus 1 whole squared. So the volume will be equals to pi times the limits, which is 1.5 and 1. The function y is 4 upon 2x minus 1 whole squared, and we'll whole square this before we start integrating. So after whole squaring, this will become 16 upon 2x minus 1 to the power 4. We will now bring 2x minus 4 into the numerator. So this will become 16 into 2x minus 1 to the power minus 4. Integrating, we'll add 1 to the power and then divide by the new power. So this will become 16 into 2x minus 1 to the power minus 3. We'll divide by the new power, which is minus 3, and also multiplied by the derivative of 2x minus 1, which is 2. So this will become 16 upon minus 6 multiplied by 2x minus 1 to the power minus 3. Once we have done the integration, we'll now apply the limits. So in the first step, we'll apply the upper limit, which is 1.5. So we'll write it as 16 into 2 into 1.5 minus 1 to the power minus 3 upon minus 6. And then we'll subtract it from the lower limit. So the lower limit is 1. So this will become 16 bracket 2 into 1 minus 1 to the power minus 3 divided by minus 6. Substituting these values in the calculator, we'll get the volume under the curve as equals to 7 upon 3 pi. So we can substitute this as it is in the calculator. There is no need for any further working. Now to find the volume under the line, for the line, the equation is y equals to 1. So for the volume, we will, in place of y, we will write 1 dx, and the limits are again 1.5 and 1. So integrating, if you whole square 1 and then we integrate, so this will become x, as 1 square will remain 1, and integral of 1 will be x. Then we'll apply the limits 1.5 and 1. So this will become 1.5 minus 1, and we'll multiply it by pi. So the volume under the line will be 0.5 pi or 1 upon 2 pi. Now to find the volume under the shaded region, we will subtract the volume under the curve, which was 7 upon 3 pi minus 0.5 pi or 1 upon 2 pi. Simplifying this, we'll get it as 6. So 7 times 2 will be 14 pi minus 2 times 3 will be, so this will become 3 pi. So the final answer will be 11 pi upon 6 for the volume of the shaded region.